Python operators. In Python, operators are symbols that perform specific operations on values and variables. The values or variables on which these operations are carried out are called operands. Operators form the core building blocks for implementing logic in program within the given programming language. Different types of operators used in Python are as follows: arithmetic operators, comparison operators, assignment operators, logical operators, bitwise operators, membership operators, and identity operators. Let us now discuss these operators used in Python one by one. First up, arithmetic operators. In Python, arithmetic operators are used to perform basic mathematical operations between two operands. These include addition, subtraction, multiplication, division, modulus or remainder, exponentiation, or power flow division. These operators enable you to carry out essential calculations in your Python programs. This is the table of the arithmetic operators for the detailed explanation. For addition, the syntax is R is equal to a plus B. This operator is used to add two operands. For example, if A is equal to 15, B is equal to 10, then a plus B is equal to 15, plus 10 is equal to 25. For subtraction, the syntax is R is equal to a minus B. This operator is used to subtract the second operand from the first operand. If the first operand is less than the second operand, the value results negative. For example, if A is equal to 20, B is equal to 5, then a minus B is equal to 20 minus 5 is equal to 15. For division, the syntax is R is equal to a by B. This operator returns the quotient after dividing the first operand by the second operand. For example, if A is equal to 15, B is equal to 4, then a by B is equal to 15 by 4 is equal to 375. For multiplication, the syntax is R is equal to a multiplied by B. This operator is used to multiply one operand with the other. For example, if A is equal to 20, B is equal to 4, then A multiplied by B is equal to 20, multiplied by 4 is equal to 80. For exponentiation, the syntax is R is equal to a double asterisk B. As this operator calculates the first operand's power to the second operand, it is an exponent operator. For example, if A is equal to 2, B is equal to 3, then a double asterisk B, that is 2, double asterisk 3, that is 2 to the power of 3. Then 2 multiplied by 2 is equal to 8. For floor division, the syntax is R is equal to a double slash B. This operator provides the quotient's floor value, which is obtained by dividing the two operands. For example, if A is equal to 15, B is equal to 4, then a double slash B is equal to that is 15. Double slash 4 is equal to 3. Here is the example code demonstrating use of arithmetic operators in Python. A is equal to 28. Initializing the value of AB is equal to 5. Initializing the value of B. Now we will print the calculated value of the following, printing the results of the arithmetic operators. Let's print one by one all the operators, and the output will be: for A is equal to 28 and B is equal to 5. Calculate the following. For addition, A plus B is equal to 33. Subtraction, A minus B is equal to 23. Multiplication, A multiplied by B is equal to 140. Division, A by B is equal to 5.6. Floor division, A double B is equal to 5 modulus. Or remainder, A modulus B is equal to 3. Exponentiation, a double asterisk B is equal to 1/15 so 368. Now let's see the comparison operators. Comparison operators in Python are used to evaluate the relationship between two values or variables, known as operands. These operators return a Boolean result, either true or false, calls based on whether the specified condition is satisfied. Python provides several comparison operators, including double equal to, not equal to, less than, or equal to, greater than or equal to, less than or greater than. Let's have an overview of comparison operators. For equal to operator, the syntax is a double equal to be equal to. Returns the true if both operands have the same value for not equal to. The syntax is A is not equal to B. It returns true if operands have the different values for less than or equal to. The syntax is a less than or equal to B. This returns true if the left operand is smaller than or equal to right for greater than or equal to. The syntax is A is greater than or equal to B. This returns true if the left operand is greater than or equal to the right one for greater than. The syntax is A is greater than B. It returns true if the left operand is greater than the right for less than. The syntax is A is less than B. It returns true if the left operand is less than the right. Let's see an example code for the comparison operator in action. A is equal to 15. Initializing the value of AB is equal to 20. Initializing the value of B. Let's print these values. Evaluating and displaying the comparison results of all the operators, and the output will be for A is equal to 15 and B is equal to 20. Check. The following are A and B equal. A equal to B. This is false. Second, are A and B not equal? The answer is true. Third one is a less than or equal to B. The answer is true. Fourth one is a greater than or equal to B. The answer is false. Fifth one is a greater than B. The answer is false. Sixth one is a less than B. The answer is true. Next up, we will see the assignment operators. In Python, assignment operators are used to assign the values of the right-hand expression to the left hand variable that is called operand. These operators not only assign values, but can also perform operations like addition, subtraction, multiplication, and more, all in a shorthand form. Python provides a variety of assignment operators, including equal to assigns the value on the right to the variable on the left, plus equal to adds and assigns the result, minus equal to subtract and assigns the result asterisk equal to. This multiplies and assigns the result equal to. This divides and assigns the result modulus equal to. This assigns the remainder after division double equal to. This performs the floor division and assigns the result double asterisk equal to. This raises the power and assigns the result impers and equal to performs bitwise, and assigns the result XOR equal to performs bitwise, or and assigns the result correct equal to performs bitwise XOR and assigns the result right shift equal to performs the right shift and assigns the result left shift equal to performs the left shift and assigns the result. These operators help simplify code and make it more concise by combining assignment with operations. Now let us see the example code for assignment operators. A is equal to 25. Initialize the value of AB is equal to 4. Initialize the value of B using assignment operators, A equal to B. Print a plus equal to B, that is 25 plus 4 is equal to 29. For subtraction, a minus equal to B 29 minus 4 is equal to 25. For multiplication, A is equal to B 25. Multiplied by 4 is equal to 100 for division A equal to B. That is, 100 divided by 4 is equal to 25, a modulus equal to B. That is, 25 modulus 4 is equal to 1. This is for exponentiation. A is equal to 2. B is equal to 3. That is, a double star is equal to B, so 2 double asterisk 3 is equal to 8. That is, 2 to the power of 3 is equal to 8. For floor division A is equal to 20, B is equal to 3. That is a double splash equal to B, so 20 double slash 3 is equal to 6. Next is bitwise operators. In Python, bitwise operators works at the binary level. They compare or modify the individual bits of integer. Let's see bitwise operators. The first one is bitwise, and the syntax is $B. It returns 1 only if both corresponding bits are 1. The next operator is backtick. The syntax remains the same, that is backtick. For corret or XOR, the syntax is XOR B, it returns 1. If bits are different, the next one is bitwise not. The syntax is bitwise A, inverts all bits left shift. The syntax is a left shift. B, this shifts bits to the left by B positions right shift. The syntax is a right shift. B, this shifts bits to the right by B positions. Let us see the example code for bitwise operators. A is equal to 12 binary double 1. Sure B is equal to 5. That is binary 0101. Now let's print these operators. Here is the code of the printing. Now let's see the logical operators. Logical operators are used to evaluate expressions and make decisions in program. These operators return Boolean values true or false based on the logical relationship between the operands. Python provides the three primary logical operators, and or not. Let's understand the behavior in the case of and. If the first condition is false, the second condition is not evaluated because the result will already be false. In the case of R, if the first condition is true, Python skips evaluating this second as entire expression will be true for logical and operator. The syntax is A and B. It returns true only if both A and B are true. For logical or operator, the syntax is A or B returns true if at least one of A or B is true for logical. Not. The syntax is not a returns the opposite of Boolean value of A. If A is true, it returns false and vice versa. Let's see the example code for the logical operators. In Python, A is equal to 7. Initialize the value of a print for A is equal to 7, evaluating the following logical expressions. This is the output. Next is membership operators. In Python, membership operators are used to test whether a value or variable is a member of a sequence, like a list, tuple, or dictionary. These operators return true if the value is found in the sequence, otherwise false for operator in. Evaluates to true if the value exists in the sequence. For operator not in, evaluates to true if the value does not exist in the sequence. Next is identity operators. Python provides two identity operators is and is not. These operators are used to compare memory location of two objects, not just their values. This means two variables that have equal values may not necessarily refer to the same object in the memory. Each operator returns true if both operands refers to the same object in the memory is not. Operator returns true if both operands do not refer to the same object in the memory. So in this video, we have explored all major Python operators, including arithmetic operators, comparison operators, assignment operators, bitwise operators, logical operators, membership operators, and identity operators. Each operator was explained with its purpose, syntax, and working code example, helping you understand how they function in the real world. Python programs